Hello everyone, welcome back. In our last video, we covered the what. So what AI agents and agentic workflows are, how they're different from the old non-agentic ways of doing things. And today we're going to dive into the how. How do we actually build one of these things from scratch? I'll give you a hint. It's not just the writing of one clever prompt. As we saw, that's how you do things in the non-agentic workflows. Since we're building smarter agents now, we don't have to just write single clever prompts anymore. Now it's a full-blown development lifecycle. This is the blueprint. Let's get into it. So our first step is we have to define our agent's goals and capabilities. This sounds obvious, but it's the most critical and mostly overlooked step. Because if you don't know exactly what problem your agent is supposed to solve, then you're just playing with a very expensive autocomplete tool. So you have to be specific. Are you building a travel agent? Are you building a code summarizer? Are you building a customer support bot that can issue refunds, for example? So you need to define what job or what role your agent is going to play. So what are the inputs, for example? Is it a user's text query? Is it a voice command? What are the outputs also? Is it a booked flight as a result of each run of the agent? Is it a block of code? Is it a database entry? So all of this has to be decided. And crucially, how do you know if it's good or bad? So that's where your success criteria comes into play. So all of this is what you define in the agent goals and capabilities section. Next, we have the design of the agent architecture. So this is your agent's blueprint. Is this a one-man band or is this an entire orchestra that we build it? If you've been following along in the agent development workflows and earlier video where we talked about agentic versus non-agentic workflows, you know that what we're trying to build here is more like an orchestra, where all the different components come into play to make us have a successful agent that always delivers on its goals. So a simple agent might just be a single LLM that gets a prompt and returns an answer, but a complex agent which we're building is one that might be a multi-agent system. So you could have a planner agent that breaks down a big problem and then passes specific tasks to its executor agent, for example. Or you might have another agent, call it the critic agent, for example, that reviews the work before it's shown to the user. And this is where you decide how the whole system thinks and communicates with itself. And this is very important because in one of the examples we're going to be seeing going forward, we're going to build an agent that goes through all of these workflows. So the next item we have after the design agent architecture is the data and the knowledge sources. So an agent is useless without information. And that's where the data and knowledge sources comes into play, because where does your agent get its facts from? This is where you decide that this information can be static knowledge. Think of it like a library of your company's PDFs, internal wikis, or product manuals. Whatever set of information that you want to make available to your agent, this is where you decide what that information looks like. Or is it even dynamic data? Does your agent need to be able to pull this data from APIs, from databases, or some form of sensors, or using its tools? So this is where you decide all of that concept. And this is where you oftentimes start to think about RAG. In an earlier video, I'll link it in the description, I talked about RAG and how you can have RAG implemented. And actually Gemini just released a file search tool which you can use to implement RAG much faster. I'll leave a link to that in the description if you're not very familiar with RAG. So RAG is basically just a fancy term for you giving your agent a library card, right? So instead of just guessing, the agent can go look up the relevant facts it needs from the information sources it has available to it. So this makes sure your agent is much more smarter and it helps prevent hallucinations. So hallucinations is a very common concept you see in agents when they lack the appropriate information to answer a user's query. Okay, so next we have the model selection and prompt design. So here is where we pick the brain of the agent. So step 4, model selection and prompt design. This is where you choose what foundation model, for example, you want your agent to use. Is it a Gemini model, a Claude model, an OpenAI GPT model, or maybe a Grok model, for example? Each agent has different strengths in terms of reasoning, in terms of speed and cost. But just picking a model isn't enough, right? You have to instruct the model. And that's where prompt design comes into play. So this isn't just the user's prompt that you're passing to your agent, but it's a well-crafted system prompt that you want to guide the agent in the realization or in the performance of the goal of that agent phase, right? You can call this the agent's constitution. It's like the agent's personality or like a rule book for the agent. So you'll write a prompt that says, for example, you're a helpful agent, you are never to discuss X, but you can always format your answers as Y. You also use techniques like chain of thought thinking or React, where you want to provide your agent with the capability to be able to call some of its external tools to be able to fulfill some of the tasks that it has to perform. And next, we have the action layer. So the action layer is where we implement tools and APIs for our agent. And this is one of my favorite parts, right? Because this is what separates a simple chatbot from a true agent. A chatbot can maybe talk about or give you information about the weather, but an agent can call the weather API and tell you what the real weather is right now. A chatbot can maybe talk about your calendar or tell you what Google Calendar is, but an agent can actually connect to the Google Calendar API and actually create meetings for you on your calendar. I'll maybe tell you what the next event is on your calendar, right? Or maybe query a database, or maybe send an email or call any custom API. Next, we have reasoning and memory. So now your agent has a brain, the model, remember, and the hands, which are the tools. So how does it decide what to do? And that's step 6, reasoning and memory. The agent has to plan when a user asks a question, for example, say, what's the weather like in Paris? And can you email that information to my mom? The agent's reasoning logic has to kick in. So for example, when a user provides a prompt like that, the agent has to build a set of tasks that it wants to use to accomplish the goal for the user. And this might be A, user needs weather, so it must use say, the get weather tool to get the current weather. Then user needs an email to be sent to their mom, so it must use the send email tool, for example, to send that email to the mom. And the agent has to prioritize the order in which it's going to call those tools. So for example, let's have the first order of action will be to get the weather. So use the weather tool, get the weather for the city, say Paris. And then it calls the send email tool to send that weather information to the mom's email, right? And then finally it delivers a conclusion or closing remark to the user and tells the user the weather is XX degrees Celsius or Fahrenheit, and then that information has been sent to the user's mom, for example. And also it needs memory. So you have short-term memory to remember what the user just said. And then you have long-term memory. So maybe in a vector database, for example, to remember the preferences for the user, for example, or details from past conversations. So you can think about a use case where you want to provide the agent with a history of previous conversations. So if you have conversations with the agent that spans multiple days or multiple interactions, you want to make sure you have the history so the agent has the necessary context to be able to provide the right answer to the user at every point in time. And then next we have tuning. So this is interface design, testing, and QA. So here we have to tune the agent. This covers 2 critical areas mostly for me. And the first is the interface. So how does the human actually talk to the agent? Is it a web chat, voice interface, or maybe a command line tool interface, right? You have to think about how the user will communicate to that agent. Secondly, this is non-negotiable, testing and QA, because you want to make sure that you have agents that consistently delivers value to your users. And to be able to achieve that, you need to test and do QA on your agent. And this is where you test, you tune, and you repeat. It's a continuous process until your agent is able to continuously deliver value to the user and to achieve its goal. And even afterwards, we get to monitoring in the next step, which is a consistent process, and that's why it's a workflow. So basically, you must test everything. You must test the agent reasoning, you must test its tool execution. What happens when an API fails? You don't want users to be stuck in a dead loop. And critically, what happens when a user tries to trick the agent, for example, to perform certain actions that it's not designed to? So this is where safety guardrails comes into play, and this is where you think about all of these things. What topic are out of bounds or out of reach that the agent shouldn't be allowed to discuss or to respond? And how do you prevent it from getting stuck in a loop or calling an API 1,000 times? So this is where you begin to think about those reliability issues for your agent and how do you consistently deliver value and handle failures within the agent lifecycle. And then finally, we have deployment and monitoring. Okay, so after going through all those 7 steps so far, the final one is deployment and monitoring. Because when you've built and you've tested your agent, the next thing you want to do is to deploy that agent to your users and begin to get live feedback, right? So this technically means running your backend either on a server or maybe on some cloud function or Cloud Run or Microsoft Azure or ECS. As the case may be, whichever your hosting platform, this is where you actually make your agent available to your users. But you're not done yet. After you deploy that agent, you have to monitor the agent, like I said. You have to continuously monitor either logs or implement tracing for that agent, just so you can see the pathways in which the agent takes, for example, when a user sends a query to the agent. And we're going to see that going forward once we start implementing actual agents. Using the ADK, for example, you can implement traceability into that agent lifecycle or workflow, such that you can see all the different calls that the agent is making in and out to different APIs as it processes the user's request. Now, something else you want to track here might be your token usage as well. You want to watch your token usage and costs like a hawk, right? Because agent can consume a lot of token. Basically, in the LLM or AI world, tokens are what you pay for. The more tokens you consume, the more your bill is going to rise. So all of this monitoring data you have to constantly keep an eye on, and it feeds right back into step 1, which is where you define your agent goals. And so that's the full workflow. And as you've probably just realized, that is a lot, right? So this is a ton of complexity that someone has to manage just to be able to deploy an agentic workflow. You've got data sources, different model tools, memory systems, testing, deployment, monitoring, all spinning at once. Now think about a scenario where you have to do all of this, and all of this processes are going on simultaneously in some cases, right? So if you're building all of this from scratch, then you're building and juggling different things at the same time. And these are all complex systems in themselves. So it's a huge engineering challenge, right? But what if there was a way in which you can manage and orchestrate this entire development workflow into a simple, harmonious process, right? So what if there's a tool or framework that's designed to handle all of this complexity for you? Well, that's exactly why Google's Agent Development Kit or ADK exists. And that's exactly what we're going to cover in part 2. I'll break down what ADK is and how it's built to be model agnostic, deployment agnostic, and also compatible with everything you're already used to using. So you won't want to miss this. And that is the agent development workflow and why ADK exists. In the next video, we're going to be diving deeper into ADK. If you haven't hit the like and subscribe button, please be sure to hit the like and subscribe button so you don't miss the next video. And until then, I'll see you guys. Have a good one. Bye for now.